Sounds like we do. Okay, let's get it started. Hello everyone. Thank you for taking time to join in this session today. Today you're going to learn about the different types of search and how to use them to get the most value of your data. My name is Alex, and I'm joined today by my colleague Narendra, and we are both AWS Solutions Architect. So here's the quick agenda, what we have prepared for you today, right? So first we will take a look at the different search options and cover the use cases. Then we will talk about how the vector search is used in generative AI applications, which is by far the most popular use case that we've seen recently. Then you would apply those learnings by doing the workshop labs. We have provisioned the temporary AWS accounts for each of you. This is where you would spend most of the time with us today. Yeah, and finally, we would also briefly cover the next steps that you may consider when you're building your own intelligent search applications. So let's start from the different types of search, but before, what is really the search, right? So search is the information retrieval process to find the most relevant results to the user queries. So when the search engine process the query, it returns the most relevant information from the documents that were already indexed by the search engine previously, right? And as the modern search engine can accept different types of data like text, images, audio, and others, you need different search algorithms to be able to handle them effectively, those different search types. So one of those search types is lexical search. And it is supported by algorithms like ANT312. It is a relatively simple keyword search, the basic matching technique based on overlapping the keywords that you have in the user query and the documents that you have previously ingested into the search engine. And it also takes into consideration how frequently each keyword appears in the documents, but that's just a part of the formula. So in a nutshell, that's still keyword match. So ANT312 is the algorithm, very fast and efficient. It's limited only to text, and it also suffers from the vocabulary mismatch problem. So, which is when the lexical terms or keywords that present in the user query doesn't really match a lot of the documents that were previously ingested. And it also doesn't capture the semantic context of the query. So if you look at the example query, which is the brown jacket for men, you can basically the ANT312 will not be able to identify that brown is the color, jacket is the piece of garment, and so on and so forth, right? And that those are related. And you can easily see that in the example responses that we have put as a for that example query, right? So besides the correct matches, you also get the jackets for men without any definition of color, and you even get the brown shoes for men, which is, you know, the clear lack of the semantic context. So that's the reason for it. So to address those issues, we have added the support for semantic search. So it is the similarity search performed by comparing features that are called vectors or embeddings. We will cover those embeddings in a couple of slides later, but on a very high level, those embeddings are created by machine learning models that are called embedding models, and they're compared by calculating the distance between those vectors using algorithms such as KNN or K-nearest neighbor. So all those algorithms that we have, they're kind of some variations of that KNN. So the good thing is that the vector search is not limited by text. And depending on the embedding model, it can work with the single type of data, like usually it's text, or it can be multimodal. So it usually supports text and images, which is probably the most common multimodal embedding models available at the moment. So if we use the same query example as we used in the previous slide, you can see that we actually have much better results. And the third result is actually the dark golden men's jacket, right? So, which is not strictly brown, but you can see how similarity, semantic similarity kicks in, so it's kind of like still reasonably close to the ones. So having that dark golden jacket in the search result is a good example why it is very popular, the vector search, I mean. But does it mean we should abandon the lexical search completely? And the practice and the benchmarks and studies tells us that's not really the case. There will be the multiple cases where the exact term matching can help the overall relevancy for the search results. Like if we're talking about product catalog, for example, think of the manufacturer product numbers or the brand names, something where the actual exact number, actual exact match would help a lot with bringing the relevance up. And instead of deciding in your application layer which search, lexical or semantic to use, you can eventually use hybrid search that is also available. And what it would do, it would run both lexical and semantic search query in parallel, will calculate the relevance for each of them, then it will combine and normalize those relevances, and then return the combined results back to the query. It also supports re-ranking, which is basically the technique that would allow you to apply the different weights to the lexical search and semantic search. So then you can tailor it to your specific use case. So now that, as I promised, let's cover a little bit the vector embeddings in more detail. So the vector embeddings is basically converting the semantic meaning of text or specific features of an image into the numeric representation. So the way it works is basically produces the array of floating point numbers. That's what eventually how does vector embedded look like. Those embeddings are generated in a way that the similar documents will have their vectors similar, which means that they will have smaller distance between them. And the number of elements in that array is sometimes referred to as dimensions. So when you hear that, for example, this embedding model produces has 1024 dimensions, it basically means that it produces the array of those floating point number of the same of the 2024 numbers in that array. So when we're searching for the using the vector embeddings, we convert the user query using the same embedding model on the fly, and then we try to calculate the embeddings, the vector that we have got as the result of that conversion with the documents that were already present in the data set. And then it runs that similarity search and it gives you the top most relevant results where the difference between those vectors is the smallest. There are multiple models available, both open source and proprietary, which you can use to generate this type of embeddings for your use case. In the workshop today, we will be using Amazon Titan Text and Amazon Titan multimodal embedding models, and then you will see how you can use them to convert the documents into the embeddings and then store them within Amazon OpenSearch vector database and then make them available for search. As you probably already know, Amazon OpenSearch service comes in two flavors, and both of those deployment options support vector search. So provision deployment option allows you to have the granular control of the server configuration, has support of open source, various open source plugins, and the serverless will provide the automatic cluster sizing, automatic cluster scaling, and also has a no-code integration with Amazon Bedrock knowledge bases. So for those who doesn't know what Amazon Bedrock is a fully managed service for that provides a choice of large language models and some additional capabilities like knowledge bases or guardrails that allows you to build the generative AI applications faster. And today you will, during the workshop, you will both work with the search plugins available in the OpenSearch service, in provisioned OpenSearch service, and also use the Bedrock knowledge base integration with the OpenSearch serverless, and that would be in the lab 3. So now let me pass the mic to Narendra, who will explain what role the vector search plays in the modern generative AI applications. Thank you.
All right. Thanks, Alex. So as Alex mentioned, now let's look at the role of vector database in generative AI applications. And we'll start by looking at how generative AI is getting utilized in many different use cases. And some of the common use cases that we are seeing are around creating new experiences by building GenAI based chatbot for providing a conversational search experience for finding the required information. And another common use case is around boosting employees' productivity by helping them in finding the required information quickly and building code faster using Amazon Q for Business and Amazon Q for Developer. And Amazon Q is a fully managed service that enables you in utilizing different type of search to utilize your internal data more effectively and accelerating your code development process. And getting insight from large amount of document and making it useful for sharing the knowledge across the organization to support better business decision is another common use case. And customers are also using generative AI by using it to create new image and video based contents. And here is how a basic GenAI application works. It uses large language model to help you in completing a given task. An example would be a car insurance chatbot that can help you in finding the right insurance policies as per your requirement. So user can provide their requirement in natural language to GenAI application, and then GenAI application would create prompt with required context for the large language model to generate the text for suggesting the right policy as per the user need. But how would an LLM know what policies are offered by your business, right? It may know about insurance industry based on the generally available information on the internet, but it may not know about your policies, the policies that are offered by your business. And if a model does not know how to perform a specific task for your domain, or if it does not know about your product, the best it can do is to make things up or hallucinate and provide the wrong information with full confidence. So the response from these models are less accurate as these models are trained based on the generally available domain data. And many of these models are trained offline and may still be stuck with the information that was available at the time of model training and may not know about new policies or new offer or the new information. And many of these model providers will not share the source of their training data that is required for the verification purpose by many different organizations, so it may not work for them. So to overcome all of these limitations, you can augment the model knowledge by the information which is very specific to your business. And that is where your organization data comes into picture. It helps you in making these generic generative AI applications very specific to your business and to your customers. And RAG, or Retrieval Augmented Generation, is a framework in GenAI that enables you to make these generic GenAI application very specific to your use case by providing the information which is very specific to your business using your internal resources. And you can use OpenSearch as a vector database to store information about your business for your RAG-based application. So to use OpenSearch as a vector database for your RAG-based application, you can use ML connector to connect with a model which is external using Amazon Bedrock, or you can connect with a third-party model. So using this integration, OpenSearch would convert the input document into vector embedding before indexing them into a vector index. And when a user submits a search query, that is converted into vector embedding, and nearest neighbor search is used to retrieve the relevant information from the index data. And GenAI application then use that information to create prompt with required context for the LLM to generate the response for the user's query. And OpenSearch now offers Neural plugin that automates much of the heavy lifting in connecting to this large language model. during index time or during the search time, right? And it offers the integration with Amazon Bedrock and other third-party model. Using this integration, OpenSearch would convert the input document during index time and then index them into a vector index. And during search time, the user's query are converted into vector embedding, and then KNN is used to retrieve the relevant information from the index data. So with that in mind, now let's dive into the workshop and try out some of these learning that we have just gone through. And here is a quick overview of the workshop that you are going to do today. In this workshop, you will use an intelligent multi-model document search application that has been built with Amazon OpenSearch Service and generative AI to help you in learning about different type of search in OpenSearch Service. You will also learn to use Amazon Bedrock and LLM with serverless OpenSearch to create the foundation work for building a conversational search experience for your organization without the need to be an expert in machine learning. And we have divided this workshop into 3 labs. In the first lab, after you complete the lab setup steps, you will index some sample retail data in OpenSearch Index using a web application that you would have deployed in the lab setup steps. And then you will run a keyword-based lexical search in OpenSearch Dashboard Dev tool and also in the web application. And you will notice the limitation of lexical search with retail dataset. And in the second lab, you would create an ingest pipeline to connect with the Amazon Titan text and Amazon Titan multi-model embedding models to convert the text and image input data into vector embedding. And then you will use this pipeline to ingest data in OpenSearch KNN vector index using the web application. And then you will use both web application and OpenSearch Dashboard Dev tool to run 3 different types of search on that data: vector search, multimodal search, and hybrid search. And you would notice how the search responses changes when you use different types of search. And in the last lab, which is an optional lab, you will get hands-on experience on using the vector engine of OpenSearch Serverless and Amazon Bedrock to build a RAG-based application using large language models. You would use Amazon Bedrock knowledge base with OpenSearch Serverless to create the foundation work for building a conversational search experience, and then you can use test knowledge base feature of Bedrock to verify its functionality. And here are the AWS team members who are available to help you throughout this workshop. And feel free to reach out to any of us if you're running into any issue or if you have any questions. And yeah, we are all here. So with that, let's dive into the workshop. But let's make sure that all of you have Wi-Fi access, or if you are having any issue in connecting to the Wi-Fi, we can help you out now. No? All right, so looks like we are all good. So for this workshop, what we have done is that we have created temporary AWS account for each of you to run through the workshop. And these accounts are pre-configured with all the required resources that you need to run the workshop. And other thing is that all of these accounts would be available only for the duration of this workshop session. So make sure that you are able to complete all the steps during this period. And then another thing is that all of these accounts are deployed in a specific AWS region, which is US West 2. So make sure that when you go to AWS account for this workshop, you are in US West 2 region. Right? And other thing to consider is that all of these accounts are recycled in different workshops, right? So do not upload any personal information or confidential information into these accounts, because these accounts are recycled again. So with that, let's go to the workshop. I'll give you an overview of different steps that we need to go to the workshop, and then I will go through each of these steps in more detail in the following slides, right? So first is that you would go to https://